Today we're going to look at algebraic fractions. Our learning goals for this lesson are that by the end of this lesson you'll be able to multiply and divide algebraic fractions and add and subtract algebraic fractions together. So in order to look at simplifying algebraic fractions, what we need to make sure we do first up is, where possible, factorise and then cancel any common factors. If we can't factorise, then we can still look for any common factors that we might be able to cancel. The operations on algebraic fractions are exactly the same as with normal fractions, so all of the rules that you're about to see underneath here, they're all the same rules that applied to normal fractions. Algebraic fractions and normal fractions work exactly the same way, there's no differences there. So for addition and subtraction, we need to make sure we've got a common denominator. So for our example down here, we've got a plus b and a over b and c over d. The common factor for our denominators there is, or our lowest common multiple for b and d is b times d. So it means that we need to multiply our first fraction by d over d to get that bd on the denominator there. So we get a over b, multiplying the top and the bottom by d, we get ad over bd. And then for our second term here, c over d, we multiply the top and the bottom by b to get bc over bd. Same denominator now, you can see here. So it means that we just put it all over that same denominator, that common denominator bd, and then add the numerators together, combine the numerators. If it was subtract, the only thing that would be different would be that this would be a subtract sign, a minus sign. For multiplication, firstly we need to have a look at any common factors we can cancel, and then multiply the numerators together and then multiply the denominators together. Very similar, well, exactly the same as with normal fractions. For division, we multiply by the reciprocal of the fraction following the division sign. So if you recall the reciprocal of a fraction, if I have our fraction c over d, that's when we switch the numerators and denominators. So the reciprocal of c over d is d over c. Recall as well that if I have a, just a, then the reciprocal of a is 1 over a. And the reason for that is because if we just look at a, if we represented that as a fraction, it would be a over 1. So you can see that the reciprocal becomes there 1 over a. I should say, sorry, moving back to the previous slide, on the previous slide, that that we then just multiply the fractions normally. So once we've found, we multiply or we turn it into a multiplication by finding the reciprocal of that second fraction, the fraction following the divide sign. All you then need to do is multiply the fractions normally. So let's have a look at some examples now. Having a look at our first example here, 3 minus 9x over 3. We need to first look at any factorizations that we can make, and we can factorize the numerator in this case. Highest common factor of that expression above, that is the numerator, is going to be 3. And so if we factorize that, the highest common factor is 3. So divide the first term by 3 and we get 1. Divide the second term by 3 and we get 3x. So then expressing that as our fraction, we can then cancel the 3 divided by 3 becomes just 1. So we're left with 1 minus 3x, which is our simplification of a. Having a look at b here, b, our expression is, or our multiplication is 2 over a times a plus 2 over 4. And if we have a look here, we can make some simplifications and cancellations. On the top and bottom here, I can see I can divide the top and bottom by 2. So I'm left with here 1 and 2 if I divide the top and the bottom both by 2. And so that means on the numerator, I've got 1 times a plus 2, which is a plus 2. And then on the denominator, I've got a times 2, which is just 2a. So a plus 2 over 2a. There are no more simplifications or cancellations that I can do here. You might think that you can divide the top and the bottom by 2 here, but I can't divide a plus 2 by 2. I can divide the 2 by 2, but not the a. So we cannot go any further than that. That's as simple as it will be. Having a look at C now, our expression, our division we have here is 2x minus 4 over 3 divided by x minus 2 over 6. So what we need to do is multiply by the reciprocal of the term after the division sign. So we leave our first term the same, oops, should be a minus, 4 over 3 multiplied by 6 over x minus 2. We can have a look here at now actually factorising the 2x minus 4. The highest common factor there is going to be 2, and we're left with x minus 2. And then over 3 times 6 over x minus 2. Now we've got a number of cancellations we can make here. We've got an x minus 2 on the top and an x minus 2 on the bottom. So we can divide the top and the bottom by x minus 2 and those will cancel. I've also got a 3 and a 6 here, so I can divide the top and the bottom by 3 as well and get 6 divided by 3 is 2 and 3 divided by 3 is 1. So what I'm then left with is 2 times 2 on the numerator, which is 4, and then on the bottom I am just left with over 1. So that's just going to be 4 as the answer for the simplification of that division. Having a look at D now. D, we've got x plus 3 over 2 plus x minus 2 over 5. And because we've got an addition of two algebraic fractions here, what we need to look at is getting a highest common denominator, or lowest common denominator, sorry. So the lowest common denominator of 2 and 5 is going to be 10. So we're going to multiply the top and the bottom of the first fraction by 5 to get 10 on the bottom. So multiplying the top by 5, we get 5 times x plus 3. And then we're going to multiply the top and the bottom of the numerator and denominator of the second algebraic fraction by 2 to get the common denominator of 10 here. So then that will be 5x plus 3 plus 2x minus 2 all over 10. Then we can expand out the numerator, or the expressions in the numerator. So we get 5x plus 15 plus 2x minus 4 all over 10. And then we can collect like terms on the numerator there to simplify that down. So 5x plus 2x is going to be 7x. And 15 minus 4 is going to be 11 over 10. So we can check, we definitely need to check at each of at the last stage whether we can do any more factorisation or cancelling, and in this case we can't. We can't factorise 7x plus 11 because the highest common factor of 7x and 11 is just 1. So let's just recap those steps. So we start out by finding a common denominator and making both our fractions have that common denominator by multiplying to get that, multiplying the top and bottom of the same number for each fraction to get that. Then we combine the numerators over that common denominator. Then if we need to expand and simplify to make sure it's as simple and as elegant as possible, which is what we're trying to get down in these last few steps, getting it as simple and elegant as possible. So our last example here, E, we've got 3 over x minus 6 minus 2 over x plus 2. Now this one might look a little bit tricky. How do we get our lowest common denominator of x minus 6 and x plus 2? Well, the answer is that we need to multiply those two together, and that will be a common denominator. So if we multiply x minus 6 times x plus 2, then we will get a common denominator. So what we'll get here is we need to multiply the top and the bottom of the first fraction by x plus 2. So we get 3x plus 2 over x minus 6, x plus 2, minus 2 times, now we need to multiply the top and the bottom of the second fraction by x minus 6 over x minus 6, x plus 2. So now we have a common denominator. We can combine the numerators over that common denominator. 3 of x plus 2 minus 2 of x minus 6 all over x minus 6, x plus 2. Once again, expand and simplify, so that's going to be 3x plus 6 minus 2x, and then it's minus 2 times minus 6, so it'll be plus 12. Be very careful on that. Plus 12 all over the x minus 6, x plus 2. Now I'm going to have to be a little bit, I've run out of room down the bottom of my screen, so I'm going to come over here to that last bit, but you'll do it nice and neatly down your page. To simplify those terms together, I've got 3x and I take away 2x's to just leave x, and I've got 6 and I add 12 to get 18 plus 18 all over our x minus 6, x plus 2. Okay, so we're left with that, and there's nothing that we can simplify on the numerator or the denominators there. You just need to make sure that you're nice and clearly showing each of the steps that you've completed, and make sure that you're showing that you're making that common denominator, combining over the top of the common denominator, and then expanding and simplifying to make it as simple, compact, and as elegant as possible.